In the previous section, we described the basics of sub-VIs, reentrancy, and non-reentrancy in LabVIEW FPGA. By the end of this module, you will be able to pass FPGA items to sub-VIs. So in this section, we're going to talk about the different ways that you can pass FPGA items to sub-VIs. So for example, you can use FPGA IO controls in sub-VIs. You can pass FPGA clocks. You can pass memory items, register items, and FIFO items into sub-VIs. Now, what's the advantage of doing this? Well, if you had some code that you were doing on some I/O, for example, and you wrote it and you wanted to reuse that code for several different ports or several different lines or channels, you can reuse that as a sub-VI, and it makes your code very readable and a lot easier for you as a developer. So one of the keys of using sub-VIs is having reusable code. So let's talk about the FPGA IO control. With an FPGA IO control, what you can do is you can use a control to specify the FPGA IO channel. So if we take a look at this particular example, let's take a look at the block diagram on the right. Okay, so this is the code that is existing in our sub-VI. So notice that we have a DIO port. Okay, and that's a control where someone can select what digital I/O port they want to use, and that reference is passed into a FPGA IO node. Okay, so at that point, this sub-VI is able to do some sort of logic on a digital I/O port that is specified by a control. Okay, so now let's take a look at the block diagram on the left. So this is the main VI. Notice that we have a sub-VI with some functionality defined that acts on a digital port, and we have it 5 different times. So now we're able to reuse that code and use it with a digital port 0, digital port 1, digital port 2, digital port 3, and digital port 4. So this is also a sub-VI, so we can assume that it is sticking with the default setting of reentrant. So notice that all 5 of these things are happening at the same time for 5 different ports. So this is a nice reusable code and a great use case for using sub-VIs. So let's take a look at this in LabVIEW and see how we can do this. Okay, so let's take a look at this particular project. Okay, so in this project, we have 4 different ports, and we do want to use the same logic on all 4 of those ports. So let's go ahead and look at this particular VI that we have. Okay, so if we look at the block diagram, notice that we've created this particular block diagram kind of in the old method before we knew about sub-VIs and FPGA IO controls. Okay, so if we take a look at this, what we're doing is we've specified and we've hard-coded this IO node to work only with digital port 0. Okay, so we're going to write some data to digital port 0. We're going to wait for some time, and then we're going to also use a method of digital port 0. And we're going to now read from digital port 0. Okay, so in this case, all this code is hard-coded. If I wanted to do this with 4 different ports, then I would have to write 4 separate pieces of code that are hard-coded with port 0, 1, 2, and 3. Okay. However, if I make this into a sub-VI, that would be a way that I can reuse this code. Okay, so how would we do this? If we had this VI, notice that the FPGA IO node, there is this input here that we can create a control from. So this is a reference. I'm going to right-click this. I'm going to go to Create Control. Okay, so notice now that this particular IO node, the digital port that's associated with it is determined by this control up here. So if I look at this control up here, notice that I can go in here and now I can get digital port 0, 1, 2, or 3. Okay. So let me go ahead and update this sub-VI, and what I'm going to do is I'm going to take that reference and I'm going to pass it into my other function. So now notice that this is the digital port that this is associated with is determined by this wire. And I'm going to go ahead and pass it into this node as well. Okay, so all 3 of these FPGA IO nodes are all associated with whatever's coming in on this control. Okay. And if I wanted to make this into a sub-VI, what I could do is I can go ahead and wire this up. So now from the main VI, now that I've used the connector pane, I can actually pass in digital port 0. Okay, and let's say I wire the rest of these up. Okay, and I'm going to save this. And now I'm going to create a new VI. So if this was my main VI, what I'm going to do is I'm going to do a quick shortcut here and drag it over here. So now I've got my sub VI, which I didn't do a connector pane of, but I just wanted to show you real quick that the sub VI would show up like this on my main VI. And notice that I've got a terminal there. I can create a constant, for example, and now I can say digital port 0. And what I can do is I can actually make copies of this sub VI. And now I can set this to digital port 1, digital port 2, and digital port 3. And now I've been able to very easily reuse my code for different ports. Okay, so on this slide, we see how to create an FPGA IO control, which I just demoed. So basically, you would place a FPGA IO node in a sub VI. You would right-click the FPGA IO input and select Create Control. And then you would wire the FPGA IO control to the sub VI connector pane. That way, your main VI can actually access that control. Okay. So typically, what you want to do is you want to place down the FPGA IO node that you want. So, for example, if it's a digital port or if it's analog in or analog output. And then if you right-click and create the control from that particular FPGA IO node that's already configured, then that control will automatically be able to be configured for whatever data type that you wanted. For example, analog input or digital port. So another type of FPGA control that you can pass into sub VIs is a FPGA clock control. So on this example, we see we've created a sub VI, and inside the sub VI there is a single cycle time loop with some code in there. Okay, and what we've done here in this sub VI is we've created a control by right-clicking the input of that single cycle time loop and creating control. We've made a clock control. So that way on our main VI on the left, we're able to execute that code, which is actually just doing a pulse train, and we're able to feed it in different FPGA clocks. So now on that main VI, by using that sub VI, we've created a pulse train that's running at 40 megahertz, another pulse train that's running at 80 megahertz, and another one that's running at 120 megahertz. Okay, so this is a nice way that you can use FPGA clocks to control the different rates of a sub VI. So the way that you would create a FPGA clock control is you would place a single cycle time loop in a sub VI, right-click that source name input, and select Create Control. At that point, make sure that you wire the clock control to the sub VI connector pane so the main VI can access it. So in the same way, you can do the same thing with FPGA memory items, register items, and FIFO items. Okay, so if you want to create a sub VI that works with any of those items, create the sub VI, place the memory item, register item, or FIFO item in there, and then again, you're going to right-click that input and create a control for it. Make sure you wire that control to your sub VI connector pane, and now your main VI can access it. So this is a great way of creating reusable code and putting them in sub VIs. Okay, so real quick, just wanted to go over some FPGA control restrictions. Okay, let's go over the first one. You cannot change the value of FPGA controls and indicators while an FPGA VI runs on the development computer or when using interactive front panel communication. So basically, you can only change the value of an FPGA control on the front panel when the VI is not running. This is because FPGA control ref nums must be constant references during runtime. Another caveat, so you cannot access FPGA controls and indicators from the FPGA interface. So we haven't talked about the FPGA interface quite yet. That's something that's going to be on your host VI. So for now, the thing I want you to take out of this is you're not going to be able to access the values and change the values of the FPGA controls and indicators that we talked about in this section from a host VI that's running on RT or Windows. Lastly, you can bundle FPGA name controls into clusters with other FPGA name controls with occurrence ref nums and with other data types. However, you cannot have this kind of a cluster on the front panel of your top level FPGA VI. LabVIEW will return an error when you attempt to compile that FPGA VI. So this is okay in sub VIs, but not on your top level FPGA VI.